Alright, so welcome back to Advent of Code, and today we got to day 11, Plutonian Pebbles. So let's try to solve this one. Honestly, it looks like a lot of text, and looking just at this example here, it looks like it grows exponentially. So we'll see if we can actually brute force part 1 at least, and then for part 2 we might have to think a lot about it. And today I'm gonna use C3 because I saw a comment and maybe it's gonna be a fun language. I wasn't able to install the 3-seater grammar. I don't know why it didn't want to work, but I got the LSP working, so that at least LSP, that's decent. And I'm just gonna use syntax highlighting for C, which is pretty similar, so yeah. But I'm not sure why 3-seater didn't want to work. So if anyone knows, if anyone uses C3 on Nix and they have Nix Vim, maybe can help. But yeah, so let's see how what the problem is about. So let's start with the part 1 reading. So we have like this ancient civilization of Pluto. They were able to manipulate space-time, and historians have to explore some like a lot of corridors, infinite corridors. And we have found a set of strange space-defying stones. First they look normal, and they are arranged in a straight line. Each stone has a number, and the strange part is that when we blink, the stones change. And now we get a rule of how they change. So the number engraved on a stone changes. Other times a stone might split in two. Well, that's where the exponential part comes in, I guess, causing all the other stones to shift over a bit to make room for the new stone. Okay, and here are the rules. I guess these are the actual rules. This was just a joke. So every time you blink, the stones change simultaneously. So it's like step 1, step 2, and so on, according to the first applicable rule in this list. If a stone is engraved with number 0, it's replaced by a stone engraved with number 1. So it goes from 0 to 1. Okay, perfect. Rule 110 incoming. If the stone is engraved with a number that has an even number of digits, it's replaced by 2 stones. The first half are engraved on the left stone and the right half on the right stone. Okay, so 1000 for instance would become 10 and 0. Okay. JavaScript developers are going like insane right now because in any language I guess you can just convert to string and then split in half. Yeah. If none of the other rules apply, the stone is multiplied by 2024. Okay, so it's like first it's gonna be 0, then it's 1, then obviously it's becoming 2024, and then it splits in half, and then it splits again, and oof, you can see how fast things are gonna get out of hand. I'm curious, what about our puzzle input? It looks small, but I'm telling you, like, first part, let's see. So here is a list of numbers. It's as big as our input, not gonna lie. It's just as big as our input. Yeah, here is a longer example. Oh, I guess, no, this is the example input, okay. And after 6 blinks, it becomes this stuff, okay. In this example, after blinking 6 times, you would have 22 stones. After blinking 25 times, you would have this many stones. So we don't even care about the numbers on the stones, we just care about how many we have, right? So it's clearly gonna be a DP problem, like dynamic programming. I have no idea how it's gonna be. Like, another thing that's important is that we multiply with 2024. So all the numbers, but we also split in half, so I cannot say that there are gonna be multiples of that. yeah, whatever. So but I guess the numbers are either gonna be less than 2024 or they are gonna be multiples of 2024, right? So that's my logic here. I think that's how it's gonna go, because if they are greater than 2024, they're gonna be split in half probably at some point, so they're gonna become smaller, and if they are bigger, they were multiplied with 2024. We'll see if that helps in the dynamic programming solution, right? I mean, we could try to just get the solution for that like instantly and solve both parts in a second, because part one is okay 25 times, but the historian needs infinite corridors, so we have to do it 25,000 times. So that's not gonna work, right? So I'm pretty sure the second part, if we do it with brute force, is gonna take a few months to solve. But okay, so let's think about it. Should we try first? Let's just go with it and try to get some stuff done with C3. So C3 documentation. C3 okay. Okay, please. Nice. So this is the hello world, and then where is the get started? Learn. Perfect. So my first thing, as usual, is to read the input. So read. I mean, I already saw this one, read line, which looks pretty cool. Like, why cannot other languages do this, right? And even better is this one, is the read line. And if I look at the description, it says that it reads the entire input. Let's see if that's true actually. So I'm just gonna copy paste this stuff, and we are gonna say string, and I guess this is like, I see this a lot nowadays, like with this exclamation point, like all the languages, VLang, Odin, Zig, they all have this result type with exclamation point and question mark, which I mean is fine. The read line, we catch the excuse. I like this. Instead of calling it exception, we call it excuse, and it's like, what's your excuse for not reading the line? Okay, fine. And then we are gonna print that string just like in C. So if I C3 compile, oh, already wait. Ah, the exclamation point wasn't wait. No, but wait. I have to use void exclamation point here because it can fail. Okay. And now if I run main, and let's start actually with TMP, which is gonna be just this, right? Main TMP. Okay. I mean, it's even better because we only need one line, so it's fine. Okay, perfect. We don't even care that it doesn't read multiple lines. Then let's see if it actually reads multiple lines. No, but yeah, still okay, because we only needed one. All right. But then what's the difference between read line and t-read line? No idea. Okay, so we got the stones as a string. Next step would be function, do we have arrays? That's a good one. A slice. So we could have int array parse input, let's say. Parse input, it's gonna take in a string of the input and it's gonna return the stones, right? So how can we actually, okay, in strings, inline char array, can we split? We have strip, which is kind of nice. Starts with split. Aha, nice. So split is perfect. Temporary string split. But maybe T is like temporary. Maybe we don't want to use it. Let's do readline. Does it really? Oh, catch excuse stones. Wait, it's a compiler error. Ah, okay. Obviously. Okay, let's just delete it for now. So it's still fine. Return K. So split seems useful. And then we are probably gonna convert them to numbers. So let's see. We are gonna use this function. Hopefully that's a comment. And I'm gonna say string array stones is equal to string split. Wait, I thought the recipe works. Is it the input split or huh? Let me just return stones. I'm not sure what usize max does or allocator, but we'll see. So we split by space. Let's see what happens if we split by space. So it compiles the list, right? So it's actually like a method then, or is it? Let's call the function. So I'm gonna say parse input on, no, what? Let's call this one input actually. Do we have a rename? Okay. I guess I didn't install all the extensions and stuff, so we'll have a string array stones, and can I print 0 at 1? And then I do main tmp. Nice, so it works. Arrays, do arrays have a length? Like, can you take the length? Because if it's a slice, what like my idea of a slice is just a pointer and the length. So can you get the length? Right, it has some kind of length on it. So how can we take that? I mean, it has a recount list string. Oh, so we have a list at least. Okay, nice. copy slice to slice. That's not what I really want. Iterating over arrays. So I can iterate like this over this stuff, and then I can print it. Okay. I mean, that could be useful. Let's see. So we print fn each stone. Nice, perfect. So I guess here what I want to do is create for each reverse. Okay, I want to create a dynamic array. So let's see if we can actually do something like that. So here it's list string. Maybe we can say list int, and then replace that with, oh, that's a good point. Like, what do we, is it just int? I think so, yeah. Okay, int. Ah. Ooh. I mean, I don't think we'll need that big of a number, but we'll see. So then we can do, then we can say that this thing returns a list int then, right? And we can have a for loop over the stones. Okay, and here let's say list int. Does it make sense? And we can create a list like this. Let's call it list. And I can initialize the list. And then we might be able to push stuff into it. Okay. So instead of just printing, let's actually push the item, but we'll need to see how we can convert it, and then we can just return this. Oh, so arrays are in STD collections. Import that. I'm wondering if it makes sense to convert it into a slice at the end, but maybe we just return the list. So yeah, whatever. So then at the end we just get the list. Here we print that, and then we go back to strings. Oh, vectors. Interesting. Strings. Do we have some kind of to int function? Oh, so you can actually, like, you have types as well, like in okay. So you can see that to int can actually fail. So do we have to make the same stuff like here with catch? So we do like int number is equal to that, and if we catch excuse of number, we return it. Otherwise we do that. Can we also somehow print it in case we get it? And like, my other idea is to just continue. What if we just continue? right? So we just keep the ones that throw an error. Okay, let's see what happens. So it, oh, I forgot about the semicolon. So it just ran, no errors. Okay, perfect. So we get a list of stones. And I think what was cool about the arrays was that you could as well just index that list. Right, for some reason it got a different name down here, but it's, I assume it's the same list as this one. Okay, I guess it makes sense, right? So this is a list int. So yeah, now that we parse the input, which again was much easier than in other languages because it's just a single line of words. So imagine in JCI it would have been just words and maybe map read. So that's kind of it. And then you have 1 and 12 and we say this is a list of int. So it just works like that. So it's just that easy. But yeah, it's still we still got it. Okay, let's see if we can actually iterate the stones now. For each stone, like let's like practice a little bit of C3. So we get a stone and then item. Okay, so we actually get it. Nice. I guess the next step is to try to come up with the algorithm for solving this problem. Like we could hard code it, but I don't really like that idea because like sure, for this small example, hard coding it just to see how it looks might be fun, right? So maybe yeah, like hard coding it just to see how it looks like. But what I'm not even sure is if this is gonna work for this big one. So yeah, so I might have to just try to come up with an algorithm because again, like there are some things like for example this 0 converting to a 0, it becomes 0. So yeah, it's like a DP problem where we have 3 rules and it's probably going to be solved with a 2D array, but we need to figure out what the rows and columns mean in this and what, like, I want the cells, basically the cells in this array to represent the number of stones, and then we have to think about, okay, but what are gonna be the indices, right, for this thing. So for example, it doesn't matter, so the order of the stones doesn't matter, right? So they can be in any order, they are gonna split the same. So that idea with, oh, they move around and whatever, it's not important. They never combine with each other, right? Imagine that's like a part 2 thing, they combine together, but from what I can see they don't, right? So they only split. So then the idea is, okay, the order doesn't matter, perfect. Then maybe we can even solve it with a hash map because like 2 appears how many times, then this number appears how, yeah, I guess hash map is a might be a better solution actually, because we are gonna keep number and the counter, right? I think that could work because the numbers are gonna be quite similar, like they are gonna look similar because the operations that we can do are multiplied with 2024. split in half, multiply again. So they're gonna be kind of close to each other. I'm gonna say. Alright, so I think that's my idea for at least for part 1, trying to use a hash map. So I'm gonna see if I can actually do it. Trying to use a hash map first, like on the first pass we're gonna have only 125 and 17. So I mean, if we actually think about it, right, we can do, like on the first pass we are gonna have a hash map with 125 appears one time and 7 appears, was it 7 or am I tripping? No, 17 appears one time as well. So then after another blink we are gonna have this huge number to whatever one time, and then 1 appears one time and 7 appears one time, right? And at some point we are gonna get to something like this where 2 appears, so we are gonna have some stuff, 2 appears 2 times. And what can we do with this? Well, when we multiply it, we know that it's gonna become 4048 because that's the rule we apply, and that number appears 2 times, right? And we can do, so what's gonna be the step function? How are we gonna step from one dictionary, like from one map to another map? We're gonna start with an empty map, right? And then we are gonna take, let's say we take the 2, right? We take the 2, and let's say we have another number that's like 4048 000. For some reason we have this other number, right? So it splits in half and we have this and this. So we are gonna have already a 4048 that appears one time, and then we need to add 2 more apparitions, so 2 more occurrences. So we just do a plus when we combine when we iterate the new map. Okay, makes sense. Hopefully C3 has hash maps. Even if it doesn't, it could still work. I mean, we can just use arrays, but definitely would be nicer if it had a hash map. Language common hash map. So it has a hash map. Perfect. Yeah, so then it's kind of clear what I'm kind of thinking of doing, right? So yeah, let's see if we can actually solve it this way. Right, so let's try to actually start working on the solution. So as I said, I want to use a hash map. So let's go ahead and let's try to import hash map. So to use hash map, I think we need to import std collections. So we already have that. And do we have the hash map by default? And let's look. Also, I think there is one extra thing. So arrays. Array also, like the array class. Dynamic arrays and lists. That's the important part. And see how here we have list and it passes in the type. So it's like a generic. I'm curious, so standard library reference, is the list the same thing? Yeah, so it also has a dynamic. So it means that we have to define key value. So here I'm gonna do define map stone map, whatever. It's gonna be a hash map, and we have to say that the key is gonna be an integer, right? And the value is also gonna be an integer. So we have basically the value that's written on the stone and how many times it appears. Right. So the next step is to have a function for part one. So let's try to create a function. Maybe it's gonna be int part one, and it should take as an argument the list of stones. So it's gonna be a list int stones, right? And for now let's just say return 0. That's fine. And instead of this thing, let's do, excuse me, io print fn part 1. We do something like this, and here we can say literally part 1 of stones. So that's how we are gonna print this thing. I'm curious if you can actually like not have to write this manually, if you can just put a question mark, but who knows. So let's run this thing again. Okay, so it compiles, that's fine. We're going baby steps. So that's how you define the hash map int, but I want to define it as a stone map. So first step is to create this mapping. So let's have the stone map is gonna be a map, and can I initialize it somehow? So we were initializing a list. Shit. There was this example here which was pretty nice. We were saying something like, wait, I lost the example, but it was well, I literally have the code. It's item, no, it's list new init. So do we have a new init in hash maps? New init, cool. So I can just say new init. So I just define the map like this and then say map.new init. Cool. So this should it returns a pointer. Wait, I don't think I was looking at the right thing, but it has a new init, so it works. It has a capacity, load factor, and so on, all the good stuff about hash maps. So new init, and it returns a pointer, but I think it's fine to just new init from map, so you can also pass another map. Okay, perfect. So first step is to initialize our map. So let's do a for each, and we can use, wait, I have a for each here. For each stone in stones, right? We want to set, so yeah, I'm not sure what the operator is. We want to set a key and a value. How about, what if this operator can be like +1 or something, and you can actually say you want to just increment. But I think I heard about this one, yeah, whatever. It's like constraints or something. So if we have a key, we want to do something different. So I might just create a function that returns void, and it's gonna do something like increment stone, right? So it's gonna take in the stone map, and I think I need to pass it as a pointer somehow, like reference somehow. I don't know yet how to write that. And I want an integer for the stone, right? So what we have to do is map Okay, I don't know how to write if statements. Let's see. Oh, it's here. If, okay, perfect. If map.has key. Yeah, let's see. It's map has key. Okay. Stone. Then I want to map.get ref. Oh, we have a lot of stuff, interesting stuff. So get ref can fail. Interesting. Get entry gives you the entire entry. Uh-huh. So what can go wrong with get ref, right? Looks like it's optional, right? Or still not sure what the exclamation point actually means, but let's do it the old way, right? So we get a value, but this one can also fail. So I might as well just do get ref stone, but it doesn't help. So yeah, let's do just get. We get stone, and we are gonna have something like int value, or like count how many we have, and by default we'll have one. But if we are able to actually get a value, so this one is like this, and if we catch an excuse, we just return it, I guess. But here we already, so we shouldn't really have an error because we already checked that it exists. So what's even the point? Whatever, we just do that, and otherwise we just set it to count. Oh, it's maybe value. Okay, whatever. It's maybe like in Haskell. So then we have to map.set stone count, and here it's gonna be value plus 1 because we increment it with 1, and set shouldn't fail really. Yeah, and we just return that. So what I'm gonna say here is increment stone, and we pass in a map and the stone, and this thing can fail, but so stone map a pointer. Do I have to say it like this? It's a pointer. Void exclamation point. Okay, rethrow using that, or panic. Okay, nice. So we can actually just have something like this and it panics, because that's impossible to have. Okay, nice. So we don't have to do all of that stuff. Nice. So it's just that. Part 1 needs to return something, so let's return 0. Okay, and I'm gonna assume that it worked. Alright, I'm not sure how we can print IO, print FN. Can we somehow print the map? Is that a thing? Oh, it says struct. Can I iterate the map somehow? Well, we can take the values. We can we iterate the entries like dot items in Python? we cannot. Not a big deal, but so for each. And can we have something like key in map, and then we just print key? What is this gonna say? Expression is not possible to enumerate, but it doesn't have a function for entries. Let's say value t-list. So these are going to be the values. 1, 1 makes sense. Key t-list. So those are going to be the keys. T copy keys. Oh, so we have some deprecated stuff. Nice. Key t-list. Wait, but it's saying use t copy list. Key t-list, and key t-list is here, but I don't see the, oh my god, it jump scares me all the time. So the documentation is outdated then. Interesting. Oh, this is the maybe type. Interesting. Yeah, whatever. Yeah, pretty cool. So that's how we get the values. Okay, but how does the copy keys work? How does the copy keys work? So it just is the same thing. Okay, perfect. Nice. So that's how we get the keys. Now let's make a function that is gonna do a single step. So I think I'm gonna make it a void step, and we need to pass in stone map, but let's be careful because we don't want to change stone map. We want to have a different map that we actually return, I think, right? So we want to pass in stone map, consume it, and create a new map, which actually could be something interesting. Yeah, no, we just create a new map. So this is going to be like the result map. Let's call it res result, and we are going to return the result at the end, right? So actually, and the last thing we have to do is to get the values and sum them up. So in the end, what we have to obtain is the total count. So if we have int total is equal to 0 and total plus equals to count, right? So we have to get the total. That's the goal. So here, if for example we are gonna say map is equal to step map, we are gonna be able to do multiple steps. Now I know this allocates a bunch of memory, but who cares? It's basically C. So let's see. So this should say 0 because it's completely empty. Like we don't even have the old stones in it, right? If I comment this out, it should say 2. Nice. So it works as expected. But what should we do now? Well, let's have a for each stone in map.copy keys. So we iterate the keys at this point, right? We iterate the keys. All right. We should also say int count is equal to map dot get stone, and we panic in case it fails because it cannot fail literally. So that's how we get the count of stones. And now we have the rules. We have the rules. And we had 3 rules. The first one, if the stone is a 0, we make it a 1, right? I guess let's just hard code all the rules in here. So if the stone is 0, have numbers. If the stone is 0, then we need to insert, so we need to set. That's interesting. I'm gonna call it the result. Let me just, let's not be that annoying person. So I mean, the annoying part is that we need to get, do we have get or default? I don't think so. Like, that's what I kind of want, a get or default. We don't, so let's implement it ourselves. So function returns an integer, get or default takes in a stone map and the stone. And what should we do is, if we have a key, then we just return it, otherwise we return 0. So get or default is gonna give us the default if it's not there. Okay, perfect. So I can say something like the new count is gonna be get or default on the result, right? Because we might change the result map, so we want to get or default the stone, right? We might have a value or not, but this is gonna be an integer. So if the stone is a 0, actually that's not true. I have to do something different, right? I said the new stone, and new stone becomes a 1. So new count is new stone plus the count, right? So if you think about it, if we have a stone 0, it needs to convert into a stone 1. That's what it says here. Okay, and now you have to think about it. What if we had other zeros, or in some weird way we had already a 1? This cannot happen, but it's, I would say it's good practice to do it for all cases, right? So the new stone is a 1, but what if in the result map we already have a stone 1? For some reason we already have it, because of multiplications and division and whatnot. So maybe we had 11, let's say, so it turned into 1. So new stone is a 1, so we get our default, we add our count, so how many stones of type 0 we had to new count, and we need to set that on the result. So result dot set new stone new count. Perfect. So this is gonna set, and if the result didn't have this stone inside of it, now it has the stone. It's else if. Is it else if or okay, if and switch else keywords, if statement. Perfect. Oh, where am I? So if else, do we have else if? Else if, elif, else if. I mean, we have switch, but I was curious about the else statement. So if, okay, let's imagine we don't have that, so we are just gonna say else. So the second case is, what if we have an even number of digits, right? And the else case finally is something else. So we have to do something here, and then, as I said, is the JavaScript guys that are really happy today, but it is what it is. So the old stone's number multiplied by 2024. Let's do the last case first. So int new stone is gonna be 2024. Well, I'm hoping that we are not gonna have insane numbers that don't fit into 64 bits, because that is gonna suck. But let's just hope. So we create a new stone by multiplying 2024 with the stone. We get the new count, which is just this, and we add count to it again. So we might even be able to somehow do these things, but I don't think so, because the second case, like this one that we have to implement, is a bit different. So we multiply the stone with 2024, we get the new count as the value that the result already has plus count, and we set the result. Perfect. And yeah, now I guess it's time for that. So how can we, so this is the entire, okay, to string. Can we convert c3lang int to string? Can we convert an integer to format or something like that? Format I to a toy. Shit, I guess format is something like useful, like string literals. And maybe can we just convert, like, I'm not sure if we can just convert an integer to a string somehow. But I mean, come on, let's just do int count digits. We don't need the JavaScript way of doing it. Count digits, int number. So we have an integer counter is equal to 0. So while, looks like while is a thing in this language, which is pretty cool. While loop. So while our number is greater than 0, we have to say something like counter plus 1, and number is divided by 10. So we return the counter, and that should count. So let's think about it. If the number is 0, yeah, whatever. If the number is 0, it's gonna go on the first case anyways, so I don't care about it. But I could say, like, if number is 0, return 1, just to satisfy the people that are screaming. So let's say we had a number like 5, counter is gonna be 1. Okay, yeah, makes sense. I think that's count digits. So count digits. So if count digits of stone modulo 2 is equal to 0, then we have a different case. IO print f, and let's see the stone. So what if we do a single step? Is it gonna do something interesting? let's see what happens. Ooh, IO. It's a module. So 17 is the double digit string, so we have to do something about it. Okay, what are we gonna do about it? I mean, yeah, like we just need to do the following. So count digits. Let's create a variable for this thing. Int digits len is gonna be that. So I'm gonna do digits len. So it's even basically. Do we have a pow function? Because that would be kind of nice. There should be like a pow function, but power. I'm curious if like math functions, std math. Like we should be able to have either it's either an operator or it's because I'm just too lazy to do the to string thingy and whatever. I'm just gonna okay, we have pow. Sadly it's a double function, but we'll see if we can. I mean it's also an integer, so maybe it's gonna be also on float, sorry, so maybe it's gonna be on integer as well. So let's try it. So what I'm gonna do, right, if we have the digits len, right, so we need half of that. So let's say half len is gonna be digits len divided by 2. Hopefully this is still an integer. And then I'm gonna say int I mean if it doesn't work then it doesn't work, it is what it is. So this is gonna be like padding, I'm gonna call it, I don't know, it's gonna be, can I say something like 10 pow half len? Is that a thing? I'm curious. No. So I literally have to maybe call it like this. Did you mean the, if so please add, and like this compiler is pretty cool. It literally, it's like, if you remember when Rust was like, holy shit, all the things are cool, because it was showing you all the errors. So this is like math, wow. Cannot be converted to it. Pow broken. So pow is only on doubles, sadly. But how do I cast? Cast integer. No, I mean, I think I guess that was the, okay, so it's just like C. So I'd say double, and can I convert this thing to an integer somehow? Yeah, whatever. So it's always gonna be like integers, so I don't really do ceiling and whatnot, so it's fine. So we are gonna have int lower is gonna be the lower stone, So it's going to be stone divided by padding, and int higher is going to be stone modulo padding. So we can say lower comma higher, and that's going to be like 1 and 7, which is pretty nice. Okay, so the next step would be to do something like this, right? So we have the new stones, we have the lower stone and the higher stone. So what I'm gonna do is try to get the lower stone, and we're gonna say lower count is equal to whatever default, and this is the lower stone plus the lower count. Right, so we set it, and I think that we set it because what if lower and higher are the same value? What if they are the same value? That's gonna be interesting. So we need to do it like this. Higher count. Let's make sure we put higher everywhere. So if I run this thing now, I should see three of them. Okay, so what if we, what if we do it again? 4. I'd like to see the stones. That would be pretty cool. So for each stone map the copy keys again, IO print f. Let's do just print f. So I'm gonna print the stone and then a space and the stone, and then we can just print fn, so like a new line. So we get 1 7 and that huge number. And if I run the map, the step again, I guess we multiply. So I guess this one is gonna be split in half. So we get 253 and 0, and then this one multiplied and this one multiplied, right? So what if I run it even again? Interesting. I guess this is lame. Let's just do a for loop. For, do we have a for? I mean, there is a for each, but how do I run it over a range? Like range or something. I guess it's just while loop, but that's kind of lame. So let's have int index is equal to 0, index is less than 25. Let's see, because this should be like extremely fast, right? Like it should be almost instant, and we get 5013. So it doesn't really die once it gets to huge numbers, which is kind of nice. So how fast is it though? It's kind of slow, actually, if I think about it. But is it gonna work on this one? Is it gonna be the correct puzzle answer? Let's see. Shit, it's too high. Really, but wait. Wasn't it the right answer here? It was. Oh no, we are... that's bad. Because we get the right answer there, but... yeah. Wait, let's do the printing again, because maybe... who knows, maybe I did something wrong. So we get this stuff after our first step. Let's see. So it was 0 turned into a 1, and then we had 31, which is gonna be split in half. Interesting. Do we have the right count there? Let's see. So what I'm also gonna do is put the count as well. So we get int count is equal to map.get stone, and we panic or unwrap. Missing? The fuck? Ah, I thought it's missing from the map. I was like, what? It's missing from the print. Okay, so 1 appears twice. See, like that works, which is pretty interesting. Where does the 88 come from? It comes from 88 and 67. Nice. 3 to 1 is gonna be multiplied, so 2024 is gonna be this huge number. Then we have probably this number multiplied by 2024. Or is it... wait, where is this number? Am I blind? I don't see it. Oopsie doopsie. Wait, it's a number, like it's a real thing, that one. 60. So at least we know this one comes here. This one comes here. Is it too big or something? So this one becomes this 5-3 whatever, right? Did I check this one? I didn't. This one 1-3. Did what? It's weird. Oh my, I think I multiplied with some dumbass number. No, it's 2024. What the fuck? Wait. I'm extremely confused. Like, where does this number come from? Or like, why doesn't they like, clearly I can see this one multiplied with 2024. No, this one doesn't multiply, but this one, the first one, 2024. Oh, it's 130. It's this one, right? But then this 167 multiplied with 2024, it's 136. Like, I'm pretty sure it's like, is it too big? Like, I'm curious. Okay, so we have this number. What happens if I divide it by 2024? 53,000 and something. I don't even have that number. So maybe it is too big. Okay, let's check that. Let's have this and do multiplication and try to print it. Printfn. But it also said that my answer was too big, so it's weird how. So is it? Oh shit, the multiplication is wrong. Right? This number is too big for an int 64. Is that true? Is that really it? Is it too big? It's too big. What if we use int 128? That's fine. So you know what that means, boys. We have to change to 128. Our hash map. Okay, so honestly, let's just change all ints to int 128. It is what it is. Oh. No, like maybe I just do int 128. Just to see what I change, because I don't want to item to int. I think we'll see if that was so yeah, it was to int. I'm stupid. It was 128. You know, like in the classical high school solving problems for programming, when you have to use long and just like that you fix the issue. That's pretty nice. Hopefully, I mean, no, because the power shouldn't be that big. I'm just gonna make everything int. I mean, right, let's see if this changes anything. So int 128 cannot be implicitly converted to int. Maybe you have to use a cast. Okay, so that one with half length. Where is the half length? Maybe I have to use like int. It cannot be that big, so that's fine. Okay, and now you can see it's different numbers, right? It looks more huge, honestly, but this one was still bad. So let's see what happens if we say that we try to do 25 times and we use the TMP. We still get the same result, so that's good. And what if we run it on our other one? We get a different result. So let's check this one. Was it enough? It actually was enough to just change everything to long or whatever that was. So I'm pretty sure, as I said, part 2, let's see if I was right, if it's actually just increasing that number. So let's take a look. Only 75 times. Whoa, I'm a bit surprised. To be fair, the infinite corridors are very large. I mean, didn't I just say that? But yeah, let's try to run it 75 times. So what do we have to do here is to just copy paste the int one part and call it part 2, and it's gonna be 75 times. Well, I mean, I'm feeling a bit stupid if I do this. So actually what I'm gonna do is int 128 times, and let's call it part. And here we have times. and then I can have something like fn int 128 part 1 list int stones is just gonna be part stones 25, and then let's do part 2 is gonna be 75. I'm curious if there is any other optimization, like for instance, let's say TMP, it's such a big number, shit. Such a big number. But it was the correct result. Nice, so we actually get the right answer. And as I said, imagine that if we did the simulation, it would be impossible, so glad we actually thought about the solution from the beginning. And you know, it just made sense to use hash maps for this problem, so hopefully it all made sense for you to, like, why did we choose to use a hash map, right? Because, well, mainly, like, the short, like, long story short, we have the same stone multiple times, and the important part about this is that the order does not matter. So the order in which we have the stones doesn't matter. It's all like a trick. Here explain, like, the stones are in a line, the stones move around to make room for the other stones. That's just there to trick you into thinking that, well, oh, I have to take, like, the order matters, I have to keep them in order. But it's just like a trick to make you think that, oh, let's simulate it. But if you just think about it like, okay, I need only to keep track of how many stones of each kind I have, then it's becoming a lot more easy. So yeah, hopefully it was a useful one. And I mean, C3 is pretty cool language. I'd say it's much closer to C than maybe like Z. I think, honestly, I think VLang was the closest one to C I tried. Like, it felt the closest. And I think it's also, it has that cool feature of comparing to C, but I think all of these C-like languages have that feature. So, but yeah, I mean, still C3 is pretty nice. I mean, I really appreciate that reading is just this easy. You don't have to do any complicated stuff like we did for Rust. And I mean, I know the input was easier today, but even like reading the entire file would become easy with this. Like, you just do a while loop and read all the lines. So yeah, I mean, the solution was quite interesting. And yeah, it was funny that we had to use int 128. I mean, luckily the developer that created the language actually thought about big ints. Thank you. Imagine, oh my god, think about if we did this one in stack, like my language, we only have 64-bit numbers, so that would have been, and we don't even have hash maps. I don't even want to think about it. Like, that would be like torture to use stack for the whole advent of code. So yeah, I mean, we actually got the solution, and it wasn't that hard. But again, it's just day 11, so it's nice that we actually managed to solve it. So yeah, let's see in the next one, and maybe tomorrow, like, I'm not sure. I saw like a really weird language for but I mean, let's try. I mean, we'll see tomorrow if I actually use that one or not. So let's see tomorrow.